Integrated ML helps you make smart decisions based on your data by allowing you to easily implement machine learning. You can train predictive models on large data sets, all from within an SQL environment. Using integrated ML, it's now possible to train data models on time series data to make predictions for specific future timeframes. For example, you could predict the total amount of rainfall for a certain month based on historic weather reports by identifying trends in previous year's data. Predictions based on historic trends have important applications in many areas, including finance, supply chain, budgeting, and public health. The default syntax for integrated ML allows developers and data analysts to train a model that predicts the value of a single column based on the values of various input columns. To help you examine time series data, integrated ML now includes syntax that allows you to train a model that predicts the values of one or more feature columns based on their previous values at specific dates or times. In this case, the predictions add new rows to the table rather than new columns. To work with the time series model, you can follow the same key steps needed for any model in integrated ML. Specify a model definition, train the model on your data, and finally, make predictions. When using time-aware modeling, you can predict multiple values given continuous historical data. This differs from typical integrated ML models, which make a prediction for a given row. With time series modeling, the history of observations must be considered rather than individual observations. When you apply a time series model to a new set of data, the model runs a calibration step each time a prediction is made, so that the entire history of observations can be taken into account during prediction. In traditional integrated ML models, the value of a single feature, such as the cost of a house, is predicted based on the value of multiple input columns, such as the location, number of bedrooms, and other traits. This means the output is a column of new values for each row. In contrast, time series models use the values of columns at specific times in the past to predict the value of each column at some point in the future. For example, you might predict the value of houses in a specific location based on past sale prices. The model would output a row containing the expected house value at a specified date for each location. Let's take a look at an example in healthcare to see this in action. Hungary has been collecting data on the number of chickenpox cases across 20 different counties for the past 10 years. Data from Borsod County during these years shows that the number of cases is highly seasonal, meaning that the demand for hospital staffing and equipment is not constant year-round. To inform staff scheduling and equipment orders for the coming months, a time series model can be used to predict the upcoming case numbers. We will first create the model by running the create time series model command, specifying the model name and number of columns to predict. We will also indicate which column contains time or date information and name the source data set. You can also specify how far into the future you would like to make predictions. In this example, there are 3 columns containing data for 3 different counties, and 1 column containing the dates that correspond to each row of case number data. Next, we'll run the train model command, which takes a few moments to execute. Then run select with predictions to get the forecasted data. The output includes 60 new rows containing the predicted number of cases for each county, 1 row for each of the next 60 weeks. These predictions can then be used to make staffing and equipment decisions. Using time-aware modeling in integrated ML, you can train models on your time series data and gain insights that help you make smart, forward-thinking decisions.